So here is another numerical problem on operational amplifier that appeared in the GATE examination. The question is stated as follows. For the ideal op-amp based circuit shown below, find the voltage gain AV equal to V0 by Vi. And this is the corresponding circuit. Now, if you remember from one of our previous classes, we had considered a pretty similar type of op-amp circuit which terminated right over here. So the additional branch in this problem is this network. So you have one resistance that goes to ground followed by another one which terminates to the output node of this op-amp. But the procedure for solving this problem is very similar to what we did the last time. So we consider the concept of virtual short, and we know that voltage at the non-inverting input terminal, which is equal to 0 volt, should be the same as the voltage at the inverting input terminal. So the voltage at this node is also equal to 0 volt. And then we identify two nodes which are unknown to us. Its voltages we can name as V sub m, and at this node we can mention it as V sub n. And then we proceed with the nodal analysis. So as before, because the op-amp is an ideal one, therefore no current can enter the input terminal of the ideal op-amp because it offers infinite input resistance, and therefore if we have some current, let's say I1, that flows due to this source Vi, then the only place through which this I1 can flow is through this resistor, and therefore if we claim that this current is equal to I2, the governing equation is I1 should be equal to I2, and therefore we can formulate I1 as Vi minus 0 divided by R, and we can formulate the current I2 as voltage at this node, which is 0, minus of voltage at the other node, which is V sub m divided by R. And proceeding with this little algebra, we find that Vm is equal to negative of Vi. So the voltage at this node is the inversion of the voltage at the input terminal. So next we consider this to be another node and we apply KCL to it. So if this is the incoming current I2, there are two outgoing currents. One is I3 and the other one is I4, and therefore we can write I2 is equal to I3 plus I4. And we can proceed as before. So we know that I2 is equal to 0 minus of Vm by R. I3 should be equal to Vm minus of 0 divided by R, and the current I4 will be equal to Vm minus of Vn divided by R. And from here we find that Vn is equal to 3 times Vm, and then again Vm we had already derived it to be negative of Vi, and therefore Vn is negative of 3 times Vi. So voltage at this node is basically 3 times the voltage at this node. Now proceeding with the third node, which is this particular node, we also note that the current I4 is equal to I5 plus I6, and therefore I4 is formulated as Vm minus Vn divided by R. I5 is equal to Vn minus of 0 divided by R, and the current I6 flows from this node, so this is at Vn, to this node which is at V0, and we divide it by R. So ultimately it turns out that V0 is equal to 3 times Vn minus of Vm, and then we have already found out that Vn is equal to negative 3 times Vi and Vm is equal to negative of Vi, and therefore we simply substitute these values in this equation and we find that V0 is equal to negative of 8 times Vi. Now because the question wanted the answer to be in the form of V0 by Vi, which is the voltage gain of this particular op-amp circuit, it turns out that The answer to this problem is negative 8.